Hello, Assalamualaikum. Today we'll learn about the relaxation oscillator. This is a triangular wave relaxation oscillator. This is actually an integrator. You have a capacitor over here and a resistor R over here. At the input section, you'll be connecting the switch, and the switch will be in position 1 and position 2. Okay, and we'll look what will happen, what we'll get at the output section. Okay, first, when the switch is at position 1, you are connecting the input to a negative value, so at the output section you'll have a positive going ramp. Okay, a negative input meaning that you are in position 1 and the output will be a positive going ramp. Now we put the switch to the position 2, meaning that you are connecting a positive supply to the input, and this is a negative, so your output will be a negative going ramp. At position 2, positive input will produce a negative going ramp. Positive input will produce a negative going ramp. Okay, now we'll see what will happen if the switch is put in position 1 and 2 at a regular interval. 1, 2 at a regular interval, meaning that you have a positive going and negative going ramp. Okay, so this is what you'll get. Input negative, positive going ramp. Input positive, you have negative going ramp. So the output will be a triangular wave. The input is a square wave. Okay, so with this we'll get a triangular wave oscillator. Okay, this is the position just now, position 1, position 2. Output waveform is a triangular waveform. Now we look into a more practical circuit, because you are not going to put your switch on and off between two positions, but instead we use that integrator and connecting it to a comparator. So it will be self-generating circuit. Since this is a comparator, you are comparing this node with a 0, because this is connected to ground. Output of a comparator is a square wave. Okay, so this practical circuit, actually you have two waveform produced. At this output is a square wave, and after the integrator it is a triangular wave. Okay, the operation of the second part, the integrator, is similar to the one that I have shown just now, only that the input, instead of connecting it to the switch, we use a comparator over here. Okay, so this is the comparator output, and this is the triangular wave that is produced after the integrator. The frequency of oscillation for that triangular oscillator, Fr, is 1 over 4 R1C multiplied with R2 over R3. How do I get this? I think I don't have to show it, but it is using the similar principle of capacitor charging and discharging. Okay, and the upper threshold point, because you have a comparator, this is Vmax. Vmax is your plus VCC or plus VO saturation, so this multiplied with R3 over R2. And the lower threshold point is negative Vmax or negative VCC or negative V saturation multiplied with R3 over R2. Okay, so you see the output levels are set by the ratio of R2 over R3. Okay, this is the position of R2 and R3. For this exercise, how to determine the Fr, just simply put it into that equation just now. Fr is 1 over 4 R1C multiplied with R2 over R1, so you get it is about 8.25 kilohertz with all this value. C 0.01 micro, R1 10k, R2 33, and R3 10 kilo ohm. And this example is we call it a function generator over here, because you can produce both, okay, a square wave and a triangular waveform. This is actually something similar to the previous circuit. This is your integrator, and output of the integrator is put into a comparator. Okay, so it is the other way around. Just now you have a comparator at the input section and then followed by integrator, but this time this is an integrator. Output of integrator, you put a comparator. Actually, it just rearrange the previous circuit, so you can have both square and triangular waveform. Okay, so this is the another circuit. And last is the function generator. This is a function generator where you can produce a sinusoidal, square and a triangular waveform. Okay, the principle, this is your oscillator. Okay, this will produce a sine wave over here. So if you look, it is a sine wave. Okay, this sine wave is connected to a comparator, so right here will be a square wave. Okay, this square wave is put into an integrator. Okay, and this output will be a triangular wave. Okay, so what this capacitor and variable resistor is for you to change the frequency of the output waveform. Okay, so meaning that if you connecting it to 1 microfarad with 68 kilo ohm R7 R10, you'll get a different frequency and so on. Okay, and this one is just for the frequency also for the sinusoidal waveform. Okay, so with this I have shown you several circuits on producing a square and a triangular waveform. Thank you.